Okay, hello Year 12s. Just going to do a run through of the solutions from the exam. This is last year's SACE exam. So I'm going to sort of speak through these just so you've got an idea, and then I'll upload this document onto Daymap as well. So I've handed out some hard copies if you're in class today, but the electronic copy of this is also up on Daymap. You'll just have to go into class feed or into last week or maybe even the week before's lessons, and you can find it there, okay? I do recommend, and I told people this today, that you give yourself 2 hours to just sit down and do this under exam conditions. So do yourself a little note sheet and that sort of thing, to give yourself the best idea about where you're currently at, okay? Because we've only got a week until, you guys are actually sitting this exam for real, all right? So we see from this diagram, this first question is asking us to figure out the perimeter of this star pattern here. We see from this diagram that it's a rhombus, all right? All sides are the same, it's just a tipped over square, all right? So we have, if we just count the sides, because we know that each side is the same, we'll find that we have 16 sides, all right? And each side is 6 centimeters. 6 by 16 will give us 96 centimeters for our perimeter, okay? In terms of our area, we need to use the formula base times height to figure out the area of one rhombus. So that would be 6 times by 4.24 and then multiplied by 8 because there is 8 rhombuses or rhombi, I don't know what the plural is. And that would give us 203.52. Make sure you put your units in like I forgot to do there. All right, show that the area of the square panel of material is approximately 420 centimeters squared. All right, so to do that, square panel 20.5 times by 20.5 will give us 420.25 centimeters squared. All right. Next one, calculate the area of the square panel of material not covered by the star pattern. All right, so this is asking us for, all right, we figured out that the area of the star was 20352. That's this white bit in here. We figured out that the area of the entire square panel is 420.25. So the area that is not covered by the star pattern is just the total, take away the area of the star pattern, which gave us 216.73 centimeters squared. All right. Now, square panels of material joined together to make square quilts. 9 square panels of material are used to make a square quilt as shown over here. All right, calculate the area of this square quilt in square meters. Couple of different ways you can do this. All right, so we know that the area of one of the square panels is 203. Is 420.25 centimeters squared. And then what we've got to do there, I don't think I did the right thing. No, I didn't in my answer. So what we've got to do there, calculate the area of this square quilt in square meters. So I mistakenly 20.5 times by 3. I see what I did. I see what I've done. So I didn't do the wrong thing. That's good. All right. So what we need to do, or what I've done, is just say, okay, each one of these 3 panels is 20.5 centimeters. So from here to here. So we times that by 3, we get 61.5 centimeters, which is this side here. It's a square, so we know that that is 61.5 centimeters as well. All right. 61.5 centimeters in terms of meters is 0.615 meters. And then to figure out the area in meters squared, we would do 0.615 times by 0.615. And that'll give us the area of this whole quilt here, all right? I like to do my centimeters to meters conversions before I multiply them, so I don't have to muck around with those. I always used to get confused with the area conversions for whatever reason, so I used to do those conversions before I actually calculate the area, which is why I've done it that way. You can just do the area of the square panel, which is 420.25, times by 9, and then convert that into meters squared. That is a completely fine way to do it as well, and you should get the same answer. Calculate the minimum number of square panels of material needed to make another square quilt that has an area of at least 4 meters squared. So 4 divided by the area of that one there would give us 10.58. This is a classic example of the question where you need to round up. All right, if we round down, then we wouldn't have enough. All right, we need to round up so that we've got enough panels to make it at least 4 meters squared. All right, cool. Hopefully you're still following along. All right, question 2. We're getting into some trigonometry stuff here. We've got a diagram. I'll let you guys read that as well. What we need to do is show that the length of DF, okay, so line DF is 0.6 kilometers, okay? So first thing we need to think is, all right, this is a right angle triangle. I know 2 of my sides. The first thing I need to think is, if I can use Pythagoras, I use Pythagoras, all right? Because we don't know an angle there, so we can't use trigonometry. So we use Pythagoras. We know that it is going to be our c squared, which is our hypotenuse of 1 equals 0.8 squared plus x squared, which is df. That's the line we don't know. All right, we rearrange that and we get 1 squared is just 1, 0.8 squared is 0.64, 1 take 0.64 equals x squared. And then we move this little square root here, square root of 0.36 equals x, which is 0.6 kilometers. All right. Okay, calculate the area of the triangle DEF, which is this one here, DEF. Remember, we do half base times height. So our height is 0.8, our base is 0.6. 0.8 times 0.6 divided by 2 gives us 0.24 kilometers squared. All right. The following measurements are also known for diagram 4. It gives us some angles there. All right, so what you've got to know here is where to put these angles. So when it says write the angles for angle, write the values for angle GHF and GFH, we are talking about the angle at this middle letter and this middle letter here. So GHF is 44. So that is 44 here. And the other one was, what was it? GFH or something, was 30, and that's that one there, okay? So it's always talking about, when it says, sort of says, and sometimes it doesn't, I think this is the first time I've actually seen them do this in the exam, or first time for a while anyway. So you've got to understand that this letter, this middle letter in here, and this middle letter in here is the angle that they're actually talking about, all right? Now, show that the length of GH is approximately 0.73. All right. So, what was it after? GF, GH. Okay. So it's after this length here. Now, we know this length, we know this angle, and we know this angle. So what we can do is use sine rule to actually figure out what this side is. So we've got, and remember we sort of went through this, me trying to remember a while back now, but we have a pair, an angle and a side pair, remembering we would label this, angle B, side B, and we would label this A, all right, side A, little a, and this would be angle A. So then we can use our sine formula here of A over sine of angle A, all right, sine 30 equals 1.4, which was side B, just here, all right, over angle B, which would be that one there. I know it says G there, but if you can just remember, we talked about extracting those triangles and labeling them as making sure that we've got either little a or big A as our unknown value, so that we can more easily rearrange that equation. All right, now if you've done that correctly, you'll get something that looks like this, and then from there, we just need to times by sine 30 on both sides. So if we do that here, we would get sine 30 times by divided sine 30, so that cancels out. And then we have multiplied by sine 30 over here, and we would get 0.728 kilometers once we put that into our calculator. All right, now again, another interesting question here, because this is kind of assumed knowledge from last year, not something specifically that is sort of in the course, but it definitely can be. And they have given you the formula here. So this is sort of what I've been speaking about the last week could actually happen. So show that the area of the triangle FGH is approximately 0.35 kilometers squared. Now they've given you the formula, obviously. It follows exactly the same principles as we were talking about with our non-right angled triangle. So half AB sine of angle C. The best thing to do here is to actually start from angle C, right? So what triangle? FGH. FGH, yep, so this one here. So I would personally just start at, actually we might not be able to, because we're going to have to do both of our two sides. So 0.728 as side A, and then work back from there. All right. So we'd label this side A here, which we've already got. So that was 0.728, and then side B over here, 1.4. This would be angle B, so that's not super relevant. This would be angle A, which we don't need for this one right now, which makes this here, the 44, which is why it was important, angle C, and this is side C, okay? So the only things we actually need are side AB, which we've got here and here, 0.728 and 1.4, times by sine of angle C, which we just said was 44, and if we pop that in our calculator, we get 0.35 kilometers squared. All right, following on from that, total area that of the island that the dogs need to patrol. All right, so it's okay. It's really just figuring out, adding together all of your areas now that they've given you a few. So it's really just taking the numbers out of this question and adding them to what you've already got. Good old Simpson's rule. Okay. So what you need to do here is just follow Simpson's rule. So whichever way works for you, remembering that there's a few different ways, but it's the sum 4 times by the sum of the odds plus 2 times by the sum of the evens plus the 2 ends as well. So there's no ends here. Remember, the ends only count when they're straight lines. There's none of those here. I've done it kind of the long way, I guess. So I've done 4 times 1.56, this one here, plus 2 times 1.05, plus 4 times by 1.19. And then remember, it's W, so the width here, and this is the one I've been sort of talking about a bit in class when we did this. Sometimes they'll give you this width, other times they'll do this and they'll give you the whole distance across, and you've got to divide by how many sections there actually are, which in this case is 4. So 3.2 divided by 4 will give us 0.8. 0.8 divided by 3, W over 3, and then that Simpson's rule formula there, so which would be 3.5 kilometers squared. All right, and then all we're doing is taking our value from there, 3.5, taking it away from the value we got from this question here, doing 3.5, take away that value, and we get 2.16 kilometers squared. All right, but you're probably seeing now how connected a lot of these questions are. What I would advise you is that really make sure that you, even if, because a trap that people fall into is, I don't know how to do this, so I'm going to leave it blank. Just try something, because then what you can do is actually use whatever you get for this question, even if you know it's wrong, to actually get the 1 mark here for this question, all right? Because otherwise you've done yourself out of, 3 and then 4 marks, okay? So try and always, even if you know it's wrong, try and always get an answer so that you can get these follow-on questions correct as well. Because even if you've got this wrong, if you've done the right process here, all right, let's say you got 2.5 here, for instance, all right, and you did 3.5, take 2.5 and got 1. They would mark that correct because you've what's called followed your mistake, all right? So a little bit of exam kind of skill there, I guess. All right. Getting to the last bit of measurement. So this one here, they are asking you to, oh, this is a tough one. Well, kind of. 3 times 3 times 3 is asking you to find the volume of the cube section of the fountain. The tricky bit here is actually identifying and reading that this is an actual cube, even though it looks like a rectangle here. So you've sort of got to understand the different views that they've actually given. State the radius of a quarter sphere, given that the cube has side lengths of 3 meters. So if if this is 3 meters there, then, and they sort of fold over like that, then we know that the radius of this cube, of this sphere, on the top is going to be half of that. All right. Another one where they've given you the formula, show that the total volume of water held in the 4 quarters is approximately 14. We would just use that volume formula plus what we got here for this question to find 14.14 meters cubed. And then we're just adding on the 3 times 3 times 3 that we did in that first question, plus the amount that can be held in that sphere, all right, or the 4 quarters of the sphere. Okay, this one's just a pretty simple. Every minute, 85.5 litres of water is pumped throughout the spouts. How many litres of water will be pumped through in 1 hour? So it's just, if it's per minute, then there's 60 minutes in an hour. Away we go. That should be a really easy mark there. All right, 38.5 meters cubed. Now this will be where you need your conversion tables on your note sheet, or you need to know that meters cubed converts directly to kiloliters. And if it's asking for it in liters, we need to go to kiloliters first and then convert that to liters. So 38.5 meters cubed is equal to 38.5 kiloliters. And then there are 1,000 litres in every kiloliter, so we would multiply that by 1,000, and we would get 38,500. Okay. Okay. Where did I get? Oh yeah. Okay. So total amount of water, and then divided by how much water is in pumped out the spout in 1 hour. All right, and then so it's 7.5 hours. Okay. One assumption, again, you could do a few different things for here. State one assumption that may impact. I put down it leaks at a consistent rate. You could say that there's no blockages, or something. That's a pretty safe one though. All right, moving on to statistics. All right, so this is where a lot of your analysis stuff usually is. There's not too much in that measurement section, but this is where they cram a lot of it in. So you've got to be really, really careful with your understanding of this statistics stuff, because this is where you can sort of make or break your exam a little bit with these sort of analysis questions. Okay, so the owner made the following statement to staff. Again, you guys can read that. 50% of the population in town were going to be booking travel in the next 12 months. Now, really, it's after a reason why this statement here is either reasonable or unreasonable. Now, again, you guys can make up your own minds. I said it was unlikely to be reasonable because the people they surveyed were all previous travellers, thus they're more likely to travel again. Or you could have said that it's a very small sample size in a town of that sort of size. Okay, so either of those would be acceptable answers. State one advantage of this method here: delivering a survey to every second house, they'd get greater coverage, and they would get much more different types of people, so they all wouldn't be travellers basically. And then one disadvantage is that with that sort of thing, your participation rate might be a lot smaller. And then state what type of survey is being used. Staffs were to collect responses from every resident. If you are getting all of the responses from a particular population, that is a census. All right, now this is one of those delightful stratified sampling questions that they chuck in most years. They did it a little bit differently last year in that they wanted you to actually do a little bit of algebra, which was frustrating. That's the first time they've actually done it. I wouldn't be surprised if it was really poorly done, which I suspect it was. I wouldn't actually be surprised if they had another one of these in this year. So really this first section here, they intend to survey 500 people from the town's population of 17,000. There are 680 people in the 20 to 25 age group. Calculate the number of people in this age group that should be included in the stratified survey. So it is just the number from that selection, all right, the group divided by the total population, and then times by how many people they want to survey. I think I missed a zero off there, so I'm not sure if that's actually affected my answer. I don't think it did. No, that's fine. Hang on, give me 2 seconds. I'm just gonna double check, just so I don't want to, because I've forgotten a zero there at the 17,000. So 680 divided by equals times by 500. Yeah, it should be 20 people rather than 200. Okay, so my mistake. All right. So there are 40 people in the 50 to 55 age group that will be surveyed using the stratified sampling method. Calculate the total number of people in this age group in the town. All right, so what we've got to do is work backwards here. So it's given us the amount of people that they want to survey. We know everything else. We know we want 500 people surveyed in total. There are 40 people from this particular group that we're going to survey. There are 17,000. Again, I've done 1,700 instead of 17,000, but this is how you would actually sort of set it out. So what we do is just work back from there. 40 divided by 500, we would get 0.8. And then we would multiply by 17,000, not 1,700. All right, 17,000 from the total population. And we would get not 136. You'll get something smaller than that. Okay, so, but that's how we would figure it out. It's really just some basic sort of rearranging of the equation from there. And the good news is that that's the only possible way that they can ask you to do this question. All right. Okay. Next one's just after a stem and leaf plot. So pretty simple. We've gone through this quite recently. Is just putting this into, putting the data points into a stem and leaf plot so that it fits. Make sure you do it in order because it actually says ordered stem plot. Even if it doesn't say ordered, just do it as ordered because it's like they're likely going to have to ask you to circle a median or something like that later on, and it'd be much easier to do that without it. Okay, so always do an ordered stem plot even if it doesn't say. So that's what we've done there. And then it's giving you some statements based on this data. So the data for the boomers are more symmetrical than the data for Gen Z. I would say they're much less symmetrical. We see we've got a nice even curve there for the Gen Zs, whereas this one's almost a little bit multimodal, all right? Okay, the data for the boomers have a larger or smaller range, okay? We've got, obviously, if we look at this here, we've got a 97 and we've also got a 31. So the range of that is going to be 97 take 31, which is 36. And the range of this one, you can even see there, it's going to be a little bit smaller. So the range for the boomers is larger. One of the boomers has spent the lowest amount on a single takeaway food purchase. That is correct because we have this one here, 31. Surprise, surprise, boomers being tight asses. Okay, the amount spent on a single takeaway food purchased by one boomer appears to be an outlier. State the outlier. All right, so we can sometimes, not always, but in this case, we can identify this as an outlier for the boomers because there's no other sort of values in here. It's not like we have a gradual tail off that we can sort of say, oh yeah, well, that makes sense. But this one here, we have the next highest value is only 69, and then we go all the way up to 97. So we can identify this one as an outlier in this instance. Explain which statistical value would be a better measure of how boomers generally spend. The median, all right, because the median is always less influenced by outliers, or you can say extreme values. Either of those statements mean the same thing and are correct. This one here is just doing your 5-number summary on the graphics calculator. There's videos on the YouTube channel that show you how to do your 5-number summary. So all you need to do is input your data for that and then get your 5-number summary and fill in this table. And then from there, you are using that 5-number summary to draw your box and whisker plots, which we've gone through quite recently as well. So I'm not going to spend too much time looking at that. But you know we have our minimum value as whisker, our Q1 value as one edge of the box, our median in the middle of the, well, not the middle of the box, but our median we draw in as a straight line, and then our Q3 is our other end of the box, and then our max value is our last whisker, all right? Now what we can tell, and this is usually how these sort of go, is they'll ask you to do this, and then they'll ask you some analysis questions. All right, so tick the appropriate box that you believe data set 3 best represents the spending spending on a single takeaway food purchase. All right. Yeah, all right. So what it's basically asking us is that this data set here that they've plotted for us, is that more likely to be people 42 to 49 years or 10 to 17? And they have asked you to justify your answer. I think we can say that it's more likely to be people in this age group because people in this age group aren't going to have a lot of disposable income compared to these people here. So that makes sense in relation to what their median spend is and also their maximum spend, okay? So that's just how I would justify it. You guys, can have your own thoughts as long as you can justify that with statistics from here and some, common sense real world application. They're going to mark that question correct. Dependent variable is always in this case, it's the annual mean temperature. So it's the thing that is measured. Is the annual mean temperature. So if you think about if you ever ask this question, and sometimes they do, sometimes they don't, the independent variable is usually like a time scale or something like that. But the way that I remember it is the dependent variable is always the thing that is measured, all right, and then the independent is the other thing, okay? In this case, it's annual mean temp. Oh, I said that. That's right. Appropriate highlighted word as a number of years. All right. So that's just asking you to plot these values in a scatter plot on your graphics calculator like we've done, or like I've shown you how to do a few times as well, and then calculate get to that line of best fit screen where it's got your R squared value. And then it's asking you to, say whether it's a strong relationship or not. We know that the higher the R squared, the stronger the relationship, lower the weaker. In this case, it's given you the equation of the line, which is nice. And it's asking you to do exactly what you've done in your investigations recently and just input a time value for that and then calculate. Okay, so 120 years after 1900 and then just solve that side of the equation, and T, annual mean temperature, is 14.3425. What's it done here? There's 2 extra data points, so add those 2 points in and then recalculate your R squared value. Discuss whether the new equation of the least squares regression line, equation of the line, including the 2 extra data points, we'd be expected to get better prediction, remembering that we can be more confident about our predictions when the R-squared value is higher, all right, which is, obviously the case here. What I've said here, though, as well, because it is extrapolation, we have to have a little bit less confidence, even though the R-squared value is quite strong. But I'm pretty sure, I kind of put that in there just to add a bit of extra depth to it, but I'm pretty sure if you just said it's got an increase in R-squared value, so we can be more confident about the prediction, that would have got 2 marks. Okay, on to investments and loans. Deposits money in account, compounded monthly, so compound interest straight off the bat. All right, so N value is obviously our number of years times by how often it's compounded. So 4 times by 12 gives us 48. Interest, self-explanatory. He starts with $57,000, so that's an initial deposit that we put in as a negative in PV. And then how much can he withdraw? All right, regular monthly withdrawals. As soon as you see regular withdrawals of those words, you should be thinking that's going to be my PMT value. And then we calculate for that, and we would get $1,276.96. This one here is asking you to see how much he's got after 1 year. So we would have that 1267.96. He starts with that amount, that stays the same. What we're actually after is our N value of 12, because we're after how much is in the account after 1 year. All right, so if we change N to 12 and then calculate for our future value, that will give us how much we've actually got left. And this is, so this is where it gets tough with this investment stuff. So after 1 year, he withdraws a lump sum. All right, so we've got how much he's got after 1 year, 43,436.06. He withdraws 3,500. All right. So what he's got, take away the 3,500. All right, so he's got 39,936.06 left at that point once he's taken that out. Now, this is where you have to kind of break that down into sort of 2 separate, and they've kind of been a bit kind to you than they have been in previous years with this question, because he's now only got his present value that he's got at this 1 year. After this 1 year is our result from this question up here, 39,936. Okay, so that's what he's got at the moment. Interest rate stays the same, payment stays the same, everything stays the same, and we solve for our N value. All right, it's asked to show that he will only have approximately 33 months. All right, so we would solve for our N value there. Now, that won't always ask you to solve for the N value. It might ask you to, assume that he wants it to last the same amount of time. How much less does he have, or what is his new payment that he can withdraw, or something like that? In that case, you would solve for PMT. Okay, so again, we need to be really aware what the question's asking us for, what we need to solve for, and what pieces of information go where with these investments and loans question. All right, well, there you go. They've just asked that question there. So if it was going for the same period of time, so for 36 months, for the last 3 years, 3 times 12, 36, everything stays the same. He's got that 39,936 that we calculated earlier. His PMT that he can afford to take out is this here. That's what we calculated for. The question, again, it's in bold, so that's obviously quite important. That's a bit of a hint there. How much less? So this is 1 mark, figuring out his new payment. This is his 2nd mark, figuring out how much less it is. So it's our initial payment that he used to take out, which we had up here, take away that new one we've calculated, and it's how much less that particular is. All right. Okay, so this one's just about reading off a table, which sounds simple but is not always as easy as that. Really, it's after you just finding, referring to the table, couple age 57 years, which is this here, with average spending. So average spending would need to save by the age of 65 years. So that is this one here. All right. Really, it's just asking you to read off that table, okay? Single person, age 57 years, okay. All right, yep, so he's 57, or this is and these are the ones that you need to make sure that you get, even though they're like reading questions and they're sort of unlike some things that we went through in this topic, they're like little gimme questions. So don't take these for granted. Make sure you get these right. So all this is asking for is to do, all right, he's 65. He's going to be 65 when he retires. He's 57 at the moment. All right, 65 take 57 equals 8 years. But you need to do this part of it because it's asked you to show that, okay? Show the needs to make a quarterly contribution. So this is what he's got at the moment. Okay, I told you this up here. He's got 8 years quarterly. Okay, 8 times 4 is 32. And then interest rate is 6.2. That's generous. How much does he need to put into his fund each quarter so that he has his goal amount, all right? And we're solving for our PMT. As soon as, and I'll say this a few more times, as soon as it is asking you quarterly contribution or monthly deposit or anything like that, that should immediately tell you that we need to calculate for PMT, all right? Assumptions, the old faithful of interest rate remaining the same, and that he doesn't make any lump sum payments or he continues to, he doesn't lose his job or anything like that is fine. All right. Now, this one here is an inflation question. I know we haven't spent a whole lot of time on it, but all we need to do is that, okay, he makes the initial sort of goal is 313,000. If we factor in inflation, all we're doing is timesing it by 1 point and then the percentage of inflation, 2.1%, and raising it to the power of how many years it is, okay? So that really all we're saying there is that, yes, 313,000, that's his goal, but for it to be worth the same amount of money, once we've factored in inflation, he would actually need 615.58. Okay. Calculate. All right, so all it's asking you to do is just recalculate for n with that new goal in mind. Okay. So it was going to take him 32 quarters. It is now, once we've recalculated for that, it is now going to take him 40.23 quarters, which is 2.23 years. All right. Received a promotion, earned a higher salary, state one effect. So there's more money being deposited. If you're earning more money, your employer has to obviously deposit more super because, they have to deposit 10.5% no matter what. So more money, more super, less money, less super. Last question, I think. All right. Now this one, per annum compounded weekly. So, end value of that. Interest rate 1.37. Okay. How much money is she going to have at the end? $913. Calculate the interest that she's earned. All right, she put in $26. 26. So 26. In 6 months. So 26 weeks times by $35, what she's putting in. So she put in 910. She has 913, so she's only earned $3 in interest. She withdrew all the funds her parents gave her additional money, so she had a total of 1,000. She invested the 1,000 in a term deposit investment for 6 months with the interest paid at the end of the term. Calculate the simple interest rate required. Okay, so this one is just saying if this is going to be her goal, all right, which is $20 in interest. Okay, 1,000 take 20, so this means she's only earned $20 in interest, saying she started with 1,000. We would just do 20 divided by 1,000 times by 0.5, all right, which is what I've done. I've kind of done it a bit of a different way, but she would need 0.04 as a decimal or 4% as an interest rate. All right, this one here, calculate the total amount of money someone would have. after that second 6-month period. All right, that's just asking you to, she's had 913, she continues doing that. She ends up with 1,832.28. So just a bit of a recalculation there. Calculate the interest rate so that would reach 20,000 in 9 years. Pretty simple there. State one assumption that she hasn't made any extra payments. That's an old faithful, and she doesn't increase or decrease the frequency of payments. Explain the impact on the length of time it would take Sansa to have $20,000 in saving if the assumption in Part D changed. So all that's saying is that pick one of the things you mentioned up here and decide, all right, if she made extra payments, she would have that money in less time. Or if she increased the frequency of payments, she could have that savings in less time, okay? That's it, guys. That's the whole test. So any questions, anything like that, let me know, but we're donezo. All right, thanks.